Hi guys, this is section 7.5 and really quick I wanted to let you know that before you start on this section, please watch the video that says unit circle. You need to know what the unit circle values are before you start doing this section. Alright, so remember that radians of a unit circle is 1. That's very important that the radius is 1. So sine corresponds to your y-coordinate, because remember sine is defined as y over r, and the cosine function corresponds to your x-coordinate. Why? Because by definition cosine is x over r. Since the radius of the unit circle is 1, therefore we can say sine is just y, and cosine theta corresponds to your x value. Alright, so the rest of the trig functions are in ratios of sine, cosine, and tangent. So let's go ahead and define some things. So objective number 1, find the exact value of the trig functions using the unit circle. So remember that I told you to make everything x comma y. So we're going to say that the point is equal to x comma y. With that being said, we need to go ahead and rewrite some of these. So sine t is corresponding to y. Cosine t is corresponding to x. Tangent by definition is sine over cosine. That's the identity. So therefore tangent is y over x. Cosecant by definition, or by identity, is 1 over sine theta. So this becomes 1 over y. Secant is an identity that says it's 1 over cosine theta. So this becomes 1 over x. And finally, cotangent theta is corresponding to cosine over sine. So we can say this is x over y. Alright, we have page number 1 done. Now to move on. So the next example asks you to find the values of sine, cosine, tangent, cosecant, secant, and cotangent if point P equals negative radical 3 over 2, comma, negative 1/2. Is the point on the unit circle that corresponds to the real number. I want you to pay attention. It says unit circle. If it says unit circle, that means that x corresponds to cosine and y corresponds to sine. If it did not say the unit circle, then you would have to find your radius first. Since we know it's a unit circle, the radius is 1, that's why this works. So once again, on the unit circle, as you saw in the last video, my point corresponds to cosine, comma, sine. Okay. So with that being said, all I have to do is read this off. Cosine t at this point, which by the way is in quadrant 3. So anyways, sine is 1/2, that's 30 degrees, 180 plus 30 is 210, just for your own well-being. Anyways, cosine is negative radical 3 over 2. Sine is my y-coordinate, which is negative 1/2. Tangent is going to be, by definition, sine over cosine. So sine is 1/2 negative, and cosine is negative radical 3 over 2. I have to do a little bit of work here, because this is a complex fraction. So I reciprocate the denominator. And when I do that, I get 1 over radical 3. It's positive. The reason why is because 1, we're in quadrant 3, and 2, negative divided by negative is positive. So rationalize this out, I get radical 3 over 3. So I have my 3 values. Here's 1, 2, here's 3. Alright, let's go get the rest. So the reciprocal function of cosine is secant. So I just flip that over, and I get negative 2 over radical 3. I have to rationalize that. So this becomes negative radical 3 over 3. Okay. Next one. Cosecant. Flip that over, I get negative 2 over 1, which is just negative 2. And finally, we need cotangent. So cotangent, t, is the reciprocal of tangent, which is radical 3 over 1, which is just radical 3. Okay, so I found all of my trig values. I'm ready to move on to the next objective. Objective number 2. Know the domain and range of the trig functions. So once again, let's quickly fix this. Sine theta is y, cosine is x, tangent is y over x because tangent is sine over cosine, where x can't equal 0. The reason why x can't equal 0 is because that makes the function undefined. Cosecant is 1 over y, where y can't equal 0, same reason. Secant is 1 over x, where x can't equal 0 for the same reason. And cotangent is x over y. So we've already written all this stuff down. It's just in your notes once again. Okay, so now we're getting into some things that are going to affect the next section, which is the graphs of the trig functions. The domain of sine and cosine are both all real numbers. I just want you to know that all real numbers can be written like that. It looks like an R with an extra line. I just wanted you to see that because I'm going to use it. If you look at your unit circle, if you move around the whole entire thing, you will see that sine and cosine are never undefined. So that's why you're going to see they have a smooth curve. And by the way, when we talk about domain, we're talking about the width of the graph if we're looking at it visually. If we're looking at it analytically, we're talking about all of your possible x values. It's usually x, by the way. Your range is going to be your height of your graph. How tall is it? Range usually corresponds to your y coordinates. So just keep that in mind, and we're going to move forward through the notes. So the domain of tangent and secant, there are some problems with that. I want you to pull out that unit circle. Take a moment if you have to pause this video to do so. And I want you to look at the values of tangent at pi over 2. I also want you to look at the values at 3 pi over 2. If you look at the values of tangent, by the way, remember that's sine over cosine or y over x, and secant, which is 1 over cosine, you're going to see that at pi over 2 and 3 pi over 2, those values are undefined. So they are undefined. Okay, so do we have holes in our graph if we would graph this out, or analytically speaking, yes, we have some problems. So the domain for tangent and secant is all real numbers except for odd integer multiples of pi over 2. So let's make sure we understand what that means. Odd is an odd number. Odd numbers are 1, 3, 5, 7, 9, etc., etc. And integer means a number that continues on. So odd integers are going to be 1, 3, 5, 7. Odd integer multiples of pi over 2 are going to be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. So I just wanted you to make sure you understand the notation. All right, let's move on to the domain of cotangent and cosecant. Okay, so once again, please get out your unit circle, look at it, pause it if you have to. But what I want you to do is look at 0, and I want you to look at 180 degrees or pi. Okay, so if you look at those two values, you're going to see that cotangent, by the way, is defined as x over y, or cosecant, which is 1 over sine, so 1 over y. You're going to see that we have issues there as well because they are undefined at those multiples. Okay, so at those values, they become undefined. So the domain is going to be all real numbers except integer multiples of pi. So now we don't have the word odd there, we just have integer. So what does that mean? That means 1, 2, 3, 4. So the domain is all real numbers except for 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. Okay, the range. Remember, the range is the height of your graph. So if you look at all the y coordinates, you're going to find out that sine or cosine never fall below -1 and never go above +1. So your range is -1 to 1 for both sine and cosine. The range of cosecant and secant, and by the way, this section will totally make much more sense in 7.6. Cosecant and secant, what happens is they start at -1 and go down towards -infinity, and they start at +1 and go up towards +infinity. And the reason for this is they are reciprocals of sine and cosine. So I'll show you why that is soon. The range of tangent and cotangent, these ones are easy to remember. They're all real numbers. So for both. And once again, when you see the graph, this will make sense to you. So all of this here, you'll need to know for the first test. And like I said, you probably put the pieces together once you see the graphs. But this is on the test. And by the way, if you don't know this, it's going to affect the next section, which is Chapter 8. Okay, so Objective 3, we're on that now. Use the periodic properties to find the exact value of the trig functions. 360 degrees is the same as 2 pi, by the way. So all they're telling you is I can rotate all the way around the unit circle and come back up and around, and I'm going to have the same point values at that point. So when you've rotated beyond 360 degrees, you can bring it back to one of the 4 original quadrants and read off that value. And you'll see what I mean in a moment. So here's the definitions. You know, I can add 2 pi k to an angle, and it's going to refer it back to one of the 4 original quadrants. So k, by the way, is any integer. So k is just a variable. I can plug it in, 0, 1, 2, 3, 4, 5. For instance, if it's 0, I get 2 pi times 0. That just makes 0. So I get sine theta. If I plug in k equals 1, I get theta plus 2 pi. So that's going to be, 1 rotation around plus, that angle. Anyways, here are the periodic properties. Just know that they refer back to the originals. By the way, the period for sine, cosine, cosecant, and secant, and I'm going to go ahead and make a box around that. That's what I'm talking about right here. They are all 2 pi because sine, cosine, cosecant, and secant repeat themselves every 2 pi. The odd man out is tangent. Tangent starts repeating itself every pi value, so its period is pi. Sine and cosine, 2 pi. Tangent, pi. All right. So let's go ahead and do this last bit of problems. So this is the last bit of the video. We have to find the exact values of, or I might have lied to you, sorry. Anyways, we have to find the exact values of sine of 420. So the first thing we're going to do is find what quadrant we are in. So since we're at 420, I don't know what quadrant I'm in, so the first thing I'm going to do is I'm going to subtract out 360 degrees from that. So 420 less 360, that'll give me 60 degrees. Being that said, I'm looking for sine at 60 degrees. I know I'm in quadrant 1, sine is positive. Okay, so sine is 60 degrees. You can either use the unit circle approach or a triangle. We know that sine of 60 degrees is radical 3 over 2. So my answer is radical 3 over 2. So what do we know? We know that sine of 420 degrees is equivalent to sine of 60 degrees, which is radical 3 over 2. Okay, so let's look at point B. Tangent at 5 pi over 4. Okay, look at the unit circle. 5 pi over 4 is quadrant 3. Since I'm in quadrant 3, according to the unit circle, I know that I'm looking up tangent in degrees. It would be 225. That's equivalent to 5 pi over 4. Okay, tangent in quadrant 3 is positive. Okay, so I know my answer is going to be positive, and I know that tangent at 225 is 1. And once again, you could draw a triangle, or you could use your unit circle to know that. Okay, C. C is cosine at 11 pi over 4. And since I know that this is beyond 1 revolution around, and I also know that 2 pi is equal to 8 pi over 4. Okay, and how do I know that? It's because I built it up. So I made a common denominator of 4, multiplied 2 by 4, I got 8. Okay, so 8 pi over 4. So if I take 11 pi over 4, and I subtract 8 pi over 4, because that's 1 revolution around, I get 3 pi over 4. Okay, look at your unit circle. What is cosine at 3 pi over 4? Cosine at 3 pi over 4 is in quadrant 2. And I know that cosine is negative in quadrant 2. So since it's negative, and if I look at the unit circle, I'm going to see that my answer is going to be negative radical 2 over 2. And there you go. That is your answer. Okay, hang in there, guys. Almost done. Objective 4, last objective of the section, even odd properties. Okay, let's look at sine, cosecant. They are odd. What does that mean? That means that if I have a negative angle, I can't have that. So what I want to do is take the negative out. And when I take the negative out, it remains there for sine and cosecant. So sine and cosecant are odd. The other ones that are odd as well is tangent and cotangent. So once again, if you see a negative in front of the angle, you can't have that. So you have to apply what's called even odd properties. So tangent, cotangent, sine, and cosecant are odd. The even functions are in the center here. The even functions are cosine and secant. So if I have a negative in front of the angle, I take that out, but what happens is it becomes positive because it's even. Okay, so cosine and secant are even, everybody else is odd. So why does cosine attracted to secant? Because the other functions are odd. That's my joke that goes along with that little statement there. Okay, so once again, you can't have a negative sign in front of the angles. So if we have that, then we have to take care of it. All right, let's see the next page here. Whoops, too far. All right, find the exact value of. So I look at part A. First of all, I cannot have a negative in front of 45 degrees. So I have to rewrite this. Since sine is odd, the negative pops out, and I'm actually looking for sine of 45 degrees. According to PEMDAS, or please excuse my dear Aunt Sally, I have to find sine of 45 degrees first. Sine of 45 degrees is radical 2 over 2, and then I bring down that negative sign. So my answer is going to be negative radical 2 over 2. Okay, moving on. Once again, I can't have a negative in front of pi. So I'm looking at cosine of negative pi. Cosine is even. So I'm actually looking for cosine at pi. If you look on your unit circle, you'll see cosine at pi equals negative 1. Okay, we're done with that one. Cotangent. We can't have a negative in front of the value, so I'm going to bring it out because cotangent is odd. So I bring out the negative sign. I'm actually looking for negative cotangent at 3 pi over 2. So first I have to find cotangent at 3 pi over 2. Remember that cotangent by definition is x over y. The coordinate point at 270 or 3 pi over 2 is 0, negative 1. So I get 0 over negative 1, which is 0. Bring down the negative sign. I get negative 0. Because it's 0, it's just 0. I don't have to pay attention to the negative sign. And finally, last but not least, tangent of 37 pi over 4. All right, I know that this has gone several times around the unit circle. My advice to you, when it's that large, go ahead and change it to degrees. So I get 37 pi over 1 times 180 over pi. The pi's cancel each other out, and something happened here. Oh, this was supposed to be over 4. 4 goes into 180 45 times. So 37 times 45 is 1,665 degrees. Now I know that's several rotations around. So what I did was I took 360, I multiplied it by 2, I got 720, that's too small. Then I took and added 360 to 720, and I got 1080. That's too small. So I take 1080, add 360 to it, because that's another rotation around, and I get 1,440. That'll work. So I'm taking 1,665 and subtracting 1,440 from it, and I get 225. So once again, I just took 360 and I kept on adding 360 to it until I found the closest rotation. Okay, so what am I looking for? I'm looking for negative, because remember tangent is odd. Tangent at 225, because that's equivalent to negative tangent at 1,665. Okay, on the unit circle, if you look up 225, you'll see that tangent is 1, and because I'm in quad 3, tangent is positive. Okay, so I took care of that, and now all I have to do is bring down the negative sign, because that's what we got. And you're finished. So you're done with 7.5. Congratulations.